Okay, everybody, welcome back. We're getting started again. So the first talk of the afternoon is going to be from Brad Gorman. Brad Gorman is a technical customer service. Sorry, let me just double check that. Is the director of customer technical services at ARIN, the American Registry for Internet Numbers. And his talk today is going to be for RPI basics for network operators, what it is, why it matters, and how to use it. So please welcome Brad to the stage.
Thank you, everyone. Yes, my name is Brad Gorman, and that's the very fancy title that I have at ARIN. I'm also known as the RPKI guy, and routing security is important to me and should be important to all of us. That's why I'm here, so we'll go ahead and get started. Fancy headshot. All right, so what am I here to talk about today, or what do I want to talk about? The fundamentals of routing security, the components that go into the RPKI, which is currently today's gold standard of routing security tools in the bag. And then I'll go into the ARIN RPKI services that we offer to the community. BGP. So network engineers in the room, people who've run routers, talk layer 3, we're all familiar with BGP. BGP was made to make it easy to turn up a peering session with another network. It was very simple. It was meant to be easy to do, and the people at the other end of the network were folks who knew what was going on. So there was no mythical information behind it. It was there, and it has served its purpose. And originally, it was research institutions or educational institutions or government institutions that first started connecting their networks together. But as time has gone on, certainly it has become a commercial platform, and it is more and more important to have some form of networking routing security to keep your information. So what are some of the things that have happened in the past that point out some of the shortcomings of BGP? So a very famous one most people know, have heard about, is in 2008, the government of Pakistan decided that they didn't want people in their country to be able to access YouTube. Well, whether it was content related or other purposes, they intended to make sure that anyone within the country couldn't get to YouTube. Problem is that what Pakistan Telecom did was they attempted to black hole traffic so that anything inside of their network wouldn't be able to reach it. But in reality, what they did is they started announcing more specific networks into the internet routing table and ended up drawing YouTube traffic into Pakistan and causing general problems for a great number of people around the globe. Another way that routing security, or BGP, has been known to be compromised is in 2018. Another very famous attack and exploitation of BGP. Cyber attackers took the Amazon, the AWS DNS, and started announcing reachability to their network, and therefore were able to divert traffic to, in this case, my cyber wallet. So someone was out going, hey, let's see what we can do and see what information we can gather. And the attackers were successful in rerouting login attempts, hacked people's wallets, and were able to successfully steal a great amount of money in a matter of just minutes. Another way that BGP has been exploited is similar to what Pakistan Telecom did, but in 2021 and 2022, both Russia and Myanmar had similar reasons why they wanted to restrict the people within their borders to be able to get to the outside world and either pull information in that they could see or share information to the outside world. Certainly the Ukraine war, in the beginning, there was a healthy amount of information that was coming from people on the ground. And in that case, the Russian government attempted to block the traffic going back and forth to Twitter. And again, a very similar instance, Twitter access to many places in the world was interrupted. So here's the bad news. BGP is inherently secure, or insecure, excuse me. The information as is passed across the wire it isn't secure. It's not confidential. Most of the data is passed out in the open. And if you are able to either divert the traffic or get in the middle of where the traffic is going, it's accessible, it's readable. Advertisements aren't authorized. You know, as long as your peer on the other end has everything configured correctly, that connectivity shows up, it's made, and traffic starts getting passed. There's also no method of there's no method to verify the traffic that is coming to you is authentic and genuine. Again, BGP was made to be simple. It wasn't meant to be, or wasn't made to be secure. So really, what we have, the BGP that we all use today, or network operators run today, is arguably, it's 20 plus years old. And it is so ingrained and has been updated to a point, but the fact is it can't be fixed the way it is right now. But there's no reason to panic. Let me get into it. So the goals of routing security are to provide the network operator a way to make more informed routing decisions. Gives them the ability to say, hey, this information coming to me is genuine, or this announcement that I'm seeing is coming from, originating from a network that is supposed to be coming from. It protects resource holders, people who have the IPs, the Torics, the telehouse, the NTTs, any of the network providers that you have, your wireless provider, the network you have in your home. It is a way that those people can protect their traffic, your customer traffic, from nefarious activity. And ultimately, the goal is to reduce the overall attack surface available to either people who are trying to do bad things or through general misconfigurations causing a problem on the greater internet. What is routing security? It's a set of practices and technologies used to protect the flow of data. Simple as that. It's not internal to a data center. It's not internal to a host. It's not on a LAN. It's not in a VPN. It's a global infrastructure and the network that we all use to communicate across the world. It's meant to protect the data and make sure that it gets to the right place and to the intended recipient of the information. And strong routing security helps maintain the trust and the stability of making sure that this information is correct. It is protected from attempted attacks. It is protected from general mishandling of a configuration. Network engineers in the room, certainly you've done a maintenance period at 2 o'clock in the morning, and we all make mistakes. It's called human error for a reason. So routing security in general is a method of making sure that we, global community of the internet, can be assured that traffic coming in and out is genuine. So why is it important? Kind of gone into it. But where the internet is a place where businesses are out to make money, they are, the commercial aspect to it, sharing of information, it's no longer optional. We have to do something. And again, it is not an individual network or an individual person. It is a global problem to fix. The way the internet's connected today, I mean, there's no way that we can know something thousands of miles away, even 2, 3 network hops away, if they're doing the right thing. So whether it's someone, again, making an attempt to do bad things or people fat-fingering a configuration, that's what the intent and the goal of routing security is attempting to protect us from. So again, risks of running the networks and trying to operate those networks in a way that won't be interrupted or disrupted getting from end to end, or otherwise information being rerouted to where it shouldn't go. So how do we secure routing? Well, we could use a public key infrastructure. We can add encryption. You need to make sure that the announcements are authenticated and getting to the right place and coming from the right source. I've said it before, it's a global problem to solve. It's not you or me, it's everybody. It's not just everyone in this room, it's everyone in North America, it's everyone around the globe. It is a community effort to make sure the internet is stable. So 30 years ago now, 20 years to BGP, but 30 years ago was the advent of RPSL, the route policy language, and the internet routing registries. So what are the IRRs? Some people in the room are aware of running a network and needing to get that information about how something is supposed to be used. And the IRRs are a combination of open databases that is shared, published to the outside world, but there are 20 of them. And the information isn't always authenticated. Even though that an operator or an owner of a resource can say, hey, this is my intended use, the fact is there are very few places where this information is authentic or can be authenticated as being genuine coming from the resource holder. So what is the tool today? I got into it a little bit. It's the Resource Public Key Infrastructure, RPKI. It's not a four-letter word. You need to get comfortable with it because it's the tool moving forward in the future. I'll get a little more into it. But the RPKI is a security framework that uses the same cryptographic chain of certificates that HTTPS does. It's the same headers. It's the same codes. It's the same calls that are going across. When the tool was being developed, why reinvent the wheel? So we took advantage of something that was well known and understood and adopted it for ourselves and used it to identify and secure resources. The goal, again, we wanted to make sure that we were going to have an opportunity to better secure BGP. And its lack of security mechanisms that are built into it and have another vehicle with which to confirm or to help BGP do the right thing. So RPKI, because it is information that is both secured through the encryption of the certificates, but it is also maintained the ownership or the trust, excuse me, the actual resource holders. The knowledge is known at the RARs. Aaron is one of the regional internet registries. Please don't get confused with IRR. We all get it. We all get confused with it. But it is the only one security tool in the bag that is truly authoritative as to who is making statements about the use of resources and the confirmation from the RAR that, yes, this is the person who's authorized to do it. Why is it important? Well, it establishes that level of trust through the encryption, and it establishes that level of trust through what the trust anchor does, and the certificate authority says, hey, you are looking at information that Aaron or the other IRs have been able to confirm is genuine, authentic, and being made by the proper resource holder about the use of the information. It is meant to, and it is, protecting resource holders from the impact of accidental route leaks or nefarious activity. There are documented cases where it has helped, and there are many times where there is no documentation because how can you tell if something has worked if it's not broken? The tools are out there to do that. And trust me, but you can also search it for yourself. There are well-documented cases on how it has helped and how it has worked and has either completely derailed an attempt or a mistaken configuration before it could be impactful. And again, RPKI is allowing network operators that peer with multiple other providers and have large customer bases in a way to secure their networking and make more informed routing decisions on what they want to do and the information that comes to them through their pairings to the internet. So what is it about RPKI that is so special? What is that information that you need to put in, or the resource holders put in? And these are authoritative statements made in ROAs, route origin authorizations, and the knob is called route origin validation. So what is a ROA? A ROA is a statement that you make, or the resource holder makes, that says, this is my address, this is my prefix, this is the AS number that should be originating it, and that's the one that's going to be announcing it to the world. Well, that's great. It's a way that you can prove and let everyone know distant that this is what it should look like. This is where they should be coming from. And again, the RARs are able to make that authoritative check that says this row was created by the right resource holder and no one else has done it. So you can trust the information that you see in our database. These ROAs are the foundation of how RPKI works. Without a ROA, you can't do route origin validation, and I'll get into the specifics here. So why are they important? Well, the ROAs are covering your resources, right? They have to be there. Otherwise, you can't calculate what is a genuine or ingenuine route announcement. In terms of RPKI, it's a validity. There is a validity state that is tagged to a route announcement when origin validation is taking place. Another thing that you need to be aware of and mindful of, if you haven't already been exposed to it, is more service providers are requiring resource holders to make these statements, to create these ROAs about the use of their resources before you finish signing up for their service, before an Amazon, an Azure, an Oracle, an IBM starts announcing your resources to the internet. You need to make these ROAs, otherwise they're not going to turn up hearing. And as more and more resources do get covered, the better RPKI gets. The more links in the chain is great, but the fact that these links in the chain are stronger is what makes RPKI special. And these ROAs are the only way that we can make these really strong links in the chain. So what is origin validation? It's the first knob that RPKI is giving everyone. Any operator can implement and use and perform origin validation. Not everybody needs to run origin validation to make sure that those misconfigurations filter on, downstream, upstream. But it requires a conscious decision of that network operator to perform origin validation. Just by signing up to use Aaron's RPKI services and creating ROAs, you're doing the right thing and taking the steps to make those statements about the use of your resources. Just because you do that doesn't mean you've turned the knob. You haven't switched it on yet. You haven't started making decisions based on RPKI data that has been created in a method of establishing validity for routes that you are hearing. It's not mandatory either. The vast majority of networks that started implementing RPKI were the large carriers. The regional, the international, the global carriers were the ones that first started performing origin validation back in 2019. Into the beginning of the COVID years, then you started seeing service providers, again, like the AWS, that started making it that requirement. As time has progressed, smaller, regional, national incumbent, even maybe your wireless provider that is granting or giving your access to your announcements to the internet is likely asking you to create these ROAs. Internet exchanges are doing it as well. If you want to participate with the other membership and announce your routes across the fabric inside of the exchange, many of them are now requiring you to create ROAs because they are now performing route origin validation to make sure that the membership doesn't get flooded with invalid or incorrect announcements. Already talked about it, about validity states. What are they? So they're pretty clear. A valid route announcement is one that an announcement in BGP, the origin and the prefix, match the information that resource holder puts into their ROA. So it's a good one-to-one match. Okay, valid. Invalid, again, should be kind of straightforward. It doesn't match, a ROA doesn't match a route announcement. It could be coming from the incorrect origin network. It could be a prefix that doesn't completely match the prefix that was put inside of the ROA. Unknown is exactly, again, pretty straightforward. Unknown means that there is no RPKI data. There's no ROA that's been created that allows the validity state to even be calculated. And in that case, BGP just does its thing. Routes come in, people can ingest it, you can't make a decision, and the route is either using other information to decide whether it comes in and out. It's up to the operator to do. So there are three fundamental steps to route origin validation. First is the authorization. That's creating those ROAs. That's what we all have to do, people with IPs. You want to make sure that everybody sees what you want and it gets to where it needs to be. That's authorization. Validation. Well, in the middle of the infrastructure in the RPKI, there are software packages, aptly named validators. The real name is relying party software, but they're validators to everybody. And what they do is they go check the information that's in these databases run by the RARs to say all of that chain of certificates, all of that authority going back to the certificate authority, back to the trust anchor, is genuine. And then they start doing the calculation and figure out what is valid, what is invalid. That information is then pulled into the operator's network, and then they make the decisions on how they configure their security, on how they handle valid, invalid, not found routes. So here are a couple examples of how origin validation works, okay? So we've got, the resource holder has created a ROA for their network. And there is now one network, operator C, who has started performing origin validation. They're looking at what's in these databases, and they are making a conscious effort to say, I'm using this data so that I can protect my customers and that I don't have to process invalid announcements. I don't have to worry about any of this stuff. I'm just going to drop it to the floor and make my life easier. That's great, right? So when the authoritative and correct resource holder makes these announcements, operator C says, hey, I have taken advantage of this RPKI information. It matches what I see in an announcement coming from BGP. This is good. I'm going to pass it along to people downstream from me. And the network all the way on the left of the screen now says, hey, I have an announcement. It's coming from this AS. I'm putting it in my routing table. Now, in this example, network X is a bad actor, and they're going to be the bad actor through the whole thing. And they are now trying to announce ownership, that I am the authoritative source for this information. And it cleared off the screen, but network C says, nope, it doesn't match. I'm not going to pass this information along. But because the internet is so vast, it seems to be there's always another way to get to the destination. So bad actor says, I'm going to announce my ownership of these routes a different direction. And sure enough, equal cost, multipath. This route, this announcement makes it all the way to the other end. And operator A says, okay, I have 2 valid routes now to get there. And depending on the layer 3 device that you're using, depending on the vendor or the software, the last announcement may be tagged as the best. So in that case, bad actor has successfully hijacked the traffic. So as time has gone on, again, more networks have started performing origin validation, and now we've got 2 over here. And the person who's trying to do something nefarious is getting pretty frustrated now. there are two networks that are stopping their announcements from getting all the way across to the other end of the internet, whatever that is. And every path that they take to try to get information out to the outside world is blocked by those two operators, C and D now. But even though those two operators are making and performing origin validation and doing their part, they're really only protecting a small corner of the networks that are on this map. What you saw is that all the other networks are they're ingesting this traffic, they're passing it, it's computational, it's filling up bandwidth and pipes. They know nothing about this routing security tool, about this RPKI. They're not taking advantage of it. So what happens? They take the traffic and they pass it along. So as time has gone on, this is 2026, right? We've got a lot of operators that are performing origin validation. And as more and more operators closer to the edge of the internet, closest to the customers, start performing origin validation. In this example, bad actors are getting kind of frustrated. They are not getting the joy out of trying to masquerade as the real resource holder and how to get their information, or the attempt to have multiple eyeballs at the other end of the world to see them as the valid origin for this traffic. And in this case, now there is a much larger surface area. Let's turn that around. There's a much smaller surface area, an attempted location where there will be impact by these bad announcements. And the important thing to realize, though, and to note and to remember, all of us should take out, is that without that ROA being in place, none of these operators could perform origin validation and do their part to restrict or drop disgenuine traffic on the internet. So I said ROAs and origin validation, that's the first knob. What is the second knob? So there are now these objects called ISPs and this thing called path validation. So what does that mean? What is an ISP? An ISP is another signed statement. It's another component, another object inside of the RPKI where the operator says, hey, this is my autonomous system. And upstream from me, this is my provider. And if you see a path, an AS path, that doesn't say my provider is the penultimate hop coming back to me in that path, that's not a valid path. If it does not match what I'm telling you, path validation can take place. The idea is that you now are giving that layer 3 speaking device the ability to signal BGP, to give it a little bit more knowledge about what is good and what is bad. And again, it has an opportunity to provide another venue, another method of determining whether this is good or not. And again, giving route operators or network operators another bit of information to make good routing decisions. Now, ASPAs right now are still IETF drafts. The IETF is where many, if not most, of the networking standards are debated, drafted, and ratified that all of us have to deal with. Now, it is still a draft. There are 3 drafts going through the group that are focused on ASPAs and focused on RPKI. The first one of which was one that says, hey, this is what an ASPA is shaped like. This is what it looks. This is what's supposed to be in there. And as of now, Aaron and the European Middle East RAR RIPE have allowed and enabled the creation of ASPAs inside of our databases. While it hasn't really taken effect in the sense that all of the devices in the infrastructure aren't listening to ASPA information yet, but it gives the people that are developing that software and validating their own code to make ASPAs work moving forward in the future It's giving them access to live information. So all of the other RARs are going to be implementing and allowing the creation of ASPA objects, and hopefully that will progress the final 2 drafts through and push ASPAs to ratification in the IETF. So why path validation? I thought route origin validation was great. Well, it's a complement. It's not saying the same thing, but it is a method that is, again, further limiting the attack surface for someone trying to do a bad thing or impact from a misconfiguration. That is another benefit to running and using RPKI. It has the same validity states attached to it. It can be valid, invalid, or not found. And as we move forward towards adoption, it is going to be another great knob to turn on. Why? Origin validation only talks about, again, the origin. What ASN can it come from? By itself, it's not 100% effective. Somebody who has their mind set to it can spoof your ASN or anyone's ASN. And if their upstream providers say, okay, yeah, there's a new AS here, and they're sending me this route, I'm going to take it and pass it along. And that in itself defeats route origin validation. So utilizing path validation and route origin validation is making it more and more difficult for the bad person to do the bad thing. And again, it is further enhancing global routing security. What does path validation look like? Well, in this case, we're network A, and we've made a statement that says C and D are my upstream providers. Great, okay. So when announcements flood across the internet and get to the other end, you know, as an operator, and I have a copy of the table in my memory inside of my router, it says, okay, here's the first path of an announcement back to A, and it says, you know, to get back from here, go through C and then get back to A. Again, the internet passes traffic as many ways as it can possibly get there from here. So again, the edge network at the other end says, I have another path to get there. And again, in this case, it goes through D back to A. Great. But there's yet a third path to get out, an equal cost path, but it doesn't match the information that's in that ASPA that I have created. B is not my upstream provider. So that path coming back is invalidated at the edge router at the other end. And therefore, that path is not installed into the routing database. So what are the features that Aaron provides our community with in using RPKI? Well, there are 3 different services to choose from. The 2 main services are called hosted and delegated RPKI. Now, hosted RPKI truly is the easy button. Aaron writes the tools for you. Aaron maintains a repository of information and publishes it to the outside world. We serve as the certificate authority, so we make sure all of the cryptographic components are good. And within Aaron and globally, more than 95% of RPKI users, people who've created ROAs, people who do origin validation, use hosted RPKI products, and all the RARs provide them. The other side of the coin, and it's a very dark, deep side of the coin, is delegated RPKI. Now, delegated RPKI allows a network operator to say, hey, I want to take over the certificate authority. I want to maintain the ownership of those certificates. Whether they have a regulatory reason, whether it's the business that they're in, whether they just want to keep all of those keys to themselves, that's fine. So that network has to run its own certificate authority, and that network has to run and publish a high availability repository. And if anyone has a reason or a desire or wants to do that, you need to make sure that you're well aware of how RPKI works, and you've got the right human and technological resources in order to run RPKI services from your network. So there's a middle place, a middle ground. I already told you that the RPKI repository is very important, right? That's where all of these objects are stored. And if those objects are not available, then the information isn't, it's not that it's not valid anymore, it just isn't there anymore, right? You can't establish validity anymore. So what happens? You're rolling back to a previous state of how BGP works today. And you're losing the benefit of that inherent security, that routing security that RPKI is providing. So Aaron has a repository publication service, or RPS. So if there, again, is a regulatory requirement, or there is a we need to keep the keys close to our vest requirement, but we don't want to run this repository, hey, Aaron, do it for us. You're doing it for thousands of other people. Do it for us, please. And the vast majority of the users of the RPS and are not, enterprise networks. They're not carriers. They're, it's the leasing companies, honestly, that use it. They run their own infrastructure, but then don't want to have that repository requirement put upon them. So inside of Aaron, we have two infrastructures, two environments. One is the live environment, where all of the changes and statements that you make are going to be published and visible to the outside world. And this is the information that people will use to make decisions based on those statements that you make. We also have a test environment, the operational test and evaluation, or OT&E. OT&E is 100% feature parity with the live environment, but it is a sandbox where you can go and beat up on your configurations. You can test automation into how you're making your statements, how you're deploying RPKI in your networks. So it has all the same features and capabilities and none of the risk. We also have an API that goes to both live and test environments that is available to you, customers. If you have an infrastructure that is much broader and wider than a few nets, many Aaron members only have a /24. But then there are also many Aaron members that have tens of thousands or millions of IPs. And in those examples, it is a much more efficient and simpler way to maintain configurations using our API. You can get to all the same access and services that you can using the user interface, using the GUI. But it is, you can programmatically make your changes, test them, and implement them. We've been talking about automation a lot, and this is your way of making your configuration, doing the work that you want to do in a more efficient manner. Links to the tools. Before you get started using RPKI, there are a few things you need to know and have. You need to have IPs, IPv4, IPv6 addresses. Those addresses need to be covered by an agreement, a registration services agreement. That is a gate that is required of anyone who wants to use Aaron's RPKI services. Across Aaron, more than 93% of customers have signed these agreements, and the vast majority of resources are able and capable of being used with RPKI. As an organization or as an individual, you need to be linked to the organization, the Aaron organization, with those resources as an admin, tech, or routing point of contact. Those are the only three that have the ability to make RPKI decisions and make changes. And then, of course, you'll need to know what ASN is going to be originating your announcements, whether it's yours or someone else who is doing it for you, which could be your bring your own IP provider. It could be your DDoS provider. There are any number of reasons why it's not your ASN announcing it to the outside world. You may not even have an ASN, and someone upstream for you is doing you a favor and announcing your routes to the outside world. a bunch of links to a bunch of tools, third-party free tools that are available to everyone on the internet. Don't try and copy them all down. If you're taking pictures, great. Otherwise, this presentation will be available to you after the meeting is done. You can ask for them and I can send them to you. But not only I, many people in the community globally use these tools to get a sense of how things are going, how it's working. And yes, many of us are network engineers, software engineers in the room. Documentation's a tool as well. So again, here's a wealth of information that first-time users and experienced users alike will go and use to find out more about how RPKI is working. Many of these are frequently being updated. As changes happen, it's there for the taking. That's all I've got for you today. If you do have any questions or you want copies of the presentation or other presentations that we have, you can send either directly to me or to the team's mailbox. I travel a lot, so if you want a faster response, send it to the team box, and either I or someone else will respond to you. So thank you very much.
We do have a few minutes for a question if you want to come up to the mic. I don't think I've ever seen an RPKI talk that doesn't have a question after, so feel free to keep the momentum going.
And we're all bashful in the room. So feel free to stop me later on, ask one-on-one. I am more comfortable doing it that way, and maybe you are as well. So please come talk to me. Send me email after the fact. I'm here to help. Thank you.